So, we have been discussing about circuit analysis when both dependent and independent sources are present, and we have considered a very simple network, this network in the previous lecture, and found out the currents in various branches. For example, this current also I found out, is not I 2. Suppose 2 ohm is this resistance, and you can apply any method you like, I told you. Now, one important and what is this dependent source? I am telling it is will be represented by a diamond shaped block like this, and the polarity of the voltage will be shown, and it is telling me that whenever in this branch 4 ohm resistance I 1 flows from left to right, then there appears a voltage source there, and we got the value of I 2 earlier. Now, one important thing I would like to tell. Suppose this point I call point x. So, and this point is O. Across x O 2 ohm is connected. If I reframe the problem as telling that find out current in 2 ohm resistor by applying Thevenin's theorem. Thevenin theorem. Suppose I tell you. So, what is the first step? First step is, as we have done in network analysis with dependent sources alone, you first remove this 2 ohm resistance. So, remove this 2 ohm resistance, and the circuit will look like this now. This is the circuit, this is 4 ohm, this is 6 ohm. So, first open, remove this 2 ohm, this is the circuit, and these are the things given 10 volt. So, what I have to find out is B Thevenin's voltage from this. B Thevenin's is the open circuit voltage existing between terminal x and O. So, V x O is the open circuit voltage existing between x and O. So, this circuit is opened, and so to find out V x O, what I have to do? I have to start from O and try to reach x via any path I like. For example, I have decided I will go via this path. Now, one thing is clear, since it is open circuited, there is no current here. Okay. So, whatever current flows here, and how much is this current? I 1 value will be 10 divided by 4 plus 6, 10 is equal to 1 ampere, is not? This I 1 is equal to 1 ampere straight. If it is 1 ampere, then this voltage 2 into I 1, which is 1 ampere from left to right, this 2 I 1 will then become 2 volt, is not? And this current is 1 ampere. What is the current here? 0. And this current is 1 ampere. Therefore, what will be the voltage drop here? Plus minus 1 ampere is flowing 6 volt, 6 volt. Therefore, V Thevenin's is V x O is equal to open circuit voltage. So, start from O and try to reach x. So, it will be 6 plus 6, then minus 2, that is equal to 4 volt, is not that? Thevenin's voltage. So, to calculate Thevenin's voltage, open circuit that, keep all the sources, both independent and dependent sources present in the circuit, and calculate Vxo, which comes out to be V Thevenin's equal to 4 volt, is not? So, this is V Thevenin's and it has come out to be plus. Then next step is to calculate the R Thevenin's. Now, to calculate R Thevenin's, looking from this end, what you have to do is this: generally when we did not know about the dependent sources, the steps are that you replace all the sources by their internal impedances. If it is ideal, they should be shorted if it is a voltage source. If it is current source, it should be open circuited, we know that. But in case of both dependent and independent sources present, to find out R Thevenin's across x and O, replace, this point is important, replace the independent sources by their internal impedances. If any, internal impedances. For ideal voltage source, it should be 0, so shorted. Ideal current source, it should be open circuited. And if finite value of internal impedances are present, I will show those values in the circuit. So, here is a 10 volt independent source. So, to find out Thevenin's theorem, what I have to do is this: I have to redraw the circuit, replacing the independent sources replace. The next point is don't and keep the dependent sources, don't remove them, dependent sources, that is don't remove them from the circuit, don't remove them. So, if I do that, then this circuit will look like this will be shorted, this will be 4 ohm, it is after all resistance, this is also 6 ohm. So, these 2 points have been shorted, internal resistance is 0, ideal battery shorted, this is 6 ohm, and this I will not remove them, I will keep it here. And this relationship is this is I 1, this is 2 I 1. And I will try to find out the impedance looking from this end, is not, that is what I have to do. Now, how to find out the equivalent resistance when dependent sources are present? Okay, 4, 6 are parallel, but what to do with 2 I 1 business? Of course, I 1 is 0, is not. In this circuit, if you have replaced it by a short circuit with this open circuit, no current exists. So, 0 current, I 1 is 0. if I 1 is 0, here is a voltage which is 2 into 0, that is 0 volt, that is shorted. So, no, I am telling, I am just arguing like this, that if it is 4 6, so it is 0, then is it equal to 24 by 10? 2.4? No, is not. Acha. To find out in such a situation the R Thevenins, what you do? You connect a known source between these 2 points x and O and try to solve the circuit. So, what I will do is this, I will better redraw in the next page. So, copy this. So, this is the network. So, we go to next page and paste it. So, this is the network. I want to find out R Thevenins. Now, how to do it? That is what I was discussing. So, XO is open circuited and I have to measure the resistance offered by this whole network to U. So, what you do? You connect an external source here, sorry. So, you connect an external any source, either voltage or current source. For example, you decide that you will connect a current source or voltage source? Current source. Suppose you connect 1 ampere current source. I will connect and then I will try to measure what is the voltage of this network between these 2 points x and O. Then voltage by current will be the impedance of this network between point and x and O, that is the whole idea. So, I have connected a current source here, clear. Now, the moment you connect a current source between these 2 points, 1 ampere is flowing here or connect 10 ampere, it will be easier. Any current source, maybe 0.5 ampere will also do, but that you decide. So, once you do that, what will be the current in this branch? So, current this let me remove this I 1 business. Okay, let me keep this. This is I 1, then only this will be 2 I 1. This is known, but this 10 ampere will come here and it is getting divided into parallel resistance. So, current in this direction in this branch, because of this 10 ampere, it will be 10 into 6 divided by 10, that is 6 ampere, is not? 6 ampere will flow there, and if this is 6 ampere, you can easily verify this is 4 ampere, but arrow is important. This is the actual current which will be flowing in the circuit. Now, here it tells me that if you know this branch current from left to right, then this voltage will be 2 into I 1 with this polarity. Therefore, this circuit I will redraw, and you should be careful while you are doing this. So, this is 4 ohm, this active source is shorted, this is 6 ohm. Now, here is a voltage source with this is plus, this is minus, and here I have connected a current source. of any value 10 ampere I have chosen for, so that I mentally know the equations will be simpler, 4 ohm, 6 ohm. Then what I am telling, in this network it was 10 ampere, then it is easy to see that this current will be 6 ampere and this current will be 4 ampere. I have to calculate this voltage Vxo, this point is x. Now, how to calculate this voltage? I have to start from any point, try to reach here and see the voltage drop, etc. And what is the voltage drop between these 2 points? 2 I1 with this polarity. And what is I1 from left to right? So, left to right I1 is equal to minus 6 ampere, that you must take into account. Then you write here it is equal to minus 12 volt, is not? This is the thing. So, what will be the voltage between these 2 points? This plus this minus, this is 24 volt, is not? Minus plus 4 ampere is flowing. Therefore, Vxo will be equal to, start from this point, plus 24 volt, then minus plus to minus, minus 12 volt, is it? And this will be Vxo, which will be equal to 36 volt. So, if Vxo is 36 volt and this network is taking 10 ampere current, therefore, R Thevenin's. So, this whole network across Xo is now behaving like this. Here the current is 10 ampere, this network is 10 ampere current and the voltage between these 2 points is 36 volt, is not? That is what I have found out. This is the whole network. Therefore, R Thevenin's will be how much? 36 divided by 10, 3.6 ohm. Therefore, you see, to calculate the R Thevenin's, you should be careful not to replace the dependent sources. Dependent sources, let it be there like this, and you apply either a known voltage source or current source, it does not matter, we have discussed earlier, and then find out the voltage between these 2 points and current drawn by the circuit, the division of these two will give you R Thevenin's. Therefore, between the point x and y, we have found out earlier the value of V Thevenin's to be 4 volt, plus 4 volt it came. So, this whole network will be then a 4 volt and an impedance of 3.6 ohm, and then your terminal X and O. And the question was when I terminate this XO points by a 2 ohm resistance, is it 2 ohm, what will be the current in this? So, this current that was denoted by I 2 earlier through this 2 ohm resistance is 4 divided by 5.6. So, how much it came? 5 by 7. No, it is coming same, na? So, 5 by 7 ampere, which is same as the result we obtained earlier, I 2 in the previous lecture. We got this current I 2 20 by 7. Why 5 by 7? I 2 is this current, na? 20 by 7 or 5 by 7? I 1 is 5 by 7, this current. I 2 was how much? So, I have replaced this by 4 volt. Thevenin's voltage will be 4 volt is correct, and then Thevenin's resistance is okay, 3.6 ohm. Thevenin's voltage, it is 5 by 7 ampere. Then let us check this earlier method. Here it was how much? So, we have got I 2 equal to 5 by 7 ampere, and let us verify what we got by the general method without having Thevenin's theorem. We got I 2 to be 20 by 7 ampere, which should be 5 by 7. So, something must have gone wrong. You try to understand. You see, there I made a mistake in this line. While this equation, while 10 minus 10 by 1 equal to 62, that is equation 2. Here I made a mistake, which was equal to minus 10 I 1 plus 6 I 2, and this 10 goes to this side, this should be minus, is not? That is the thing. So, let us then correct it at least. So, these are wrong. So, this is minus 10, it should be. Please correct that. Hopefully, some of you have already noted that correction. So, if you simply add these two equations, you know, you will be getting now minus 4 I 1 plus 8 I 2 is equal to 0, if you add these two, and this will be equal to 8 I 2 is equal to 4 I 1 or 2 I 2 is equal to I 1. This is the thing, forget about this. So, I 1 equal to 4 I 2. First equation is correct, these two equations. So, put in the first equation. So, now in the first equation, if you put I 1 equal to 2 I 2. So, from equation 1, from equation 1 you get 6 I 1, I rewrite this 2 I 2 is equal to 10 plus 10, and I 1 is equal to 2 I 2. So, it will be 12 I 2 plus 2 I 2 is equal to 10, or I 2 is equal to 10 by 14, which is equal to 5 by 7 ampere. Oh, that is fine. So, some mistake was there, I think you have understood. So, no matter whether you are applying Thevenin's theorem or general method, result should come same. So, this is the way we have found out the Thevenin's equivalent of the network, understood. So, I 2 is equal to 5 by 7 ampere and R Thevenin is equal to 3.6 ohm. So, important point is that one. Achha, another way people try to find out the R Thevenins is, that is, if a network is given, how to find out R Thevenins. Network is given between 2 points x and O. There may be dependent and independent sources. Now, we know that. Now, open circuit voltage, open these two, get V Thevenins, which is equal to V XO, open circuit condition, that is fine. To calculate R Thevenins, what you have to do? You replace the independent sources by their internal impedances, keep the dependent sources present, and excite these 2 points x and O with a known source, maybe a current source, maybe a voltage source, whatever it is. If you excite it to a current source, try to find out what is V XO now. Then V XO by this current will give you the R Thevenins. Another way of finding out V Thevenins you know that it is true for any type of network that you find out the V Thevenin's value, V Thevenin's, that is V open circuit voltage, and also find out the short circuit current here. Open circuit voltage you find out between X and O, and you calculate the short circuit current when you short circuit this. In both the cases, keep all the sources to be present, dependent, independent, whatever it is. Then R Thevenin's, as you know, will be V Thevenin's by ISC. So, open circuit voltage, another way of calculating Thevenin's impedance is to find out the open circuit voltage and find out the short circuit current, is not? Because this circuit, if it is replaced by V Thevenin's, we know that this is the open circuit voltage and this is R Thevenin's. What will be this current when these two terminals are shorted? ISC is nothing but V Thevenin's by R Thevenin's. So, R Thevenin's is the open circuit voltage divided by short circuit current. So, R Thevenin's is V Thevenin's by ISC. So, depending upon convenience, if you can foresee that this method if I adopt, result will come quickly, adopt that method. So, by any method you can do it. Okay. For example, whatever time is left, let me do only that part. That is, suppose I want to calculate R Thevenin's open circuit voltage, I have already calculated. So, I will short circuit X and O and calculate the short circuit current of this network. Got the point? So, this let me copy. Let me copy this and go to next page and paste it. So, this was the original network. Okay. This you erase. I do not know anything about this. So, this is also, let me erase. So, it was some voltage source here, na? 10 volt. So, this was the circuit, this is independent source 10 volt and this is the thing. It was connected and it was given that if this current is I1 is left to right, this is 2 I1. Is not, that is the thing given. Now, V Thevenin's how much we have got? Already calculated 4 volt. So, 4 volt, V Thevenin's is 4 volt. Now, I will calculate R Thevenin's in this way. Okay, in this network, I will calculate what will be the short circuit current. If you short circuit this, calculate this current ISC, short circuit current, and do not remove any sources present. So, short circuit current let us calculate, and this short circuit current can be calculated easily. Remove all these values we do not know whether they prevail or not. So, this is the situation. I have to solve the network with X and O shorted. Once again it is this circuit is to be solved. So, generate two equations and try to solve the current. Obviously, if this is ISC, this current here in this branch, it will be I 1 minus I s c, is not, apply KCL. Then the voltage drop between these 2 points is 6 into I 1 minus I s c. So, apply here the KVL equation in this loop, and please do it correctly. I may make mistake, point that out. This is 4 I 1, that is what I have assumed. So, this minus 4 I 1, it is dekho, minus 4 I 1, and then this is minus 6 into I 1 minus I s c, and that is equal to 0. So, how many unknowns are there? 2 unknowns, I 1 and I s c. So, this is one equation, and this if you simplify, it will be 10 I 1, this minus 10 I 1, I will take it to that side, and this is plus 6 I s c. If I take it to the other side, it will be 6 I s c, and on this side what things will remain is 10. Minus 4 I 1, minus 6 I 1, minus 10 I 1. So, plus 10 I 1, minus 6 I s c, plus 6 I s c this side, minus 6 I s c, and 10 I keep it there. So, this is equation 1. You have to peacefully do this thing. So, this is the, in this loop, the KVL equation in this loop. Similarly, you apply KVL equation in the outer loop or in this loop, whichever independent loop. So, from this to this, if I apply it in the outer loop, it will be from this to this point 10, this loop I am doing, plus 10 minus 4 I 1, that is this, then from this to this minus 2 I 1, and here 0, nothing, and you have reached this point, and this is equal to 0. So, plus 10 minus 4 I 1 and minus 2 I 1 is equal to 0. So, the second equation is, from this equation you get 6 I 1 is equal to 10, or I 1 is equal to 10 by 6, which is equal to 5 by 3 ampere. But this is not short circuit current. Short circuit current will be obtained now from this. So, I 1 is known, 10 into 5 by 3 minus 6 I s c is equal to 10, or 6 I s c is equal to 50 by 3 minus 10, which is equal to 50 minus 30, 20 by 3, or I s c, short circuit current, is equal to 20 by 3 into 6, and this is 10 by 9 ampere. Now, what I am telling, then R Thevenin's has to be V Thevenin's by I s c. What is V Thevenin's? 4 volt divided by 10 by 9, which is equal to 36 divided by 10, which is coming same. How much it is? 3.6 ohm. So, this is another way of calculating R Thevenin's. Therefore, you should be careful when a network is having both dependent and independent sources, and if you are asked to calculate Thevenin's equivalent of a circuit which are having multiple number of dependent and independent sources, while calculating R Thevenin's and V Thevenin's, you should be careful. To calculate the open circuit voltage, do not remove any source, calculate VXO, writing KVL, KCL only, or whatever method you like. And similarly, to while calculating the R Thevenin's, between these 2 points, replace the independent sources only by their internal impedances and do not do anything with the dependent sources. Then 2 ways you can calculate R Thevenin's. One is then you excite the network with a known voltage or current source and then find out the current drawn by the circuit if you have excited this with a voltage source and then find out R Thevenin's. Or another way, given as network with so many dependent independent sources, another way of telling this, calculate open circuit voltage and calculate short circuit current and do not remove any sources in these 2 cases, and then divide these 2, you will get R Thevenin's. Open circuit voltage will give you V Thevenin's. Hope you have understood this. We will in the next class, we will take a slightly complicated circuit with dependent. Mind you, only one thing I would like to tell you, that in a network when both voltage and current sources will be present, which may be dependent, independent, whatever it is. Suppose if I say find out the current in a particular branch by applying superposition theorem, then also you should be careful. So, in a circuit, what I am trying to tell is that when there will be several sources, both dependent and independent sources present, and if I ask you to find out a particular branch current by applying superposition theorem, then what you should do? You should consider one independent source at a time and keep the dependent sources present. Do not play with them, they will remain intact to find out, and only because of independent sources you will find out the currents in various branches. I think you have got the idea. Next time I will solve a problem, and so the calculation of R Thevenin's is somewhat tricky, V Thevenin's is tricky. That is, although we replace the sources by their internal impedances, but not with the dependent sources. Do not do anything, let them in the circuit, let them be in the circuit. Similarly, while applying superposition R Thevenin's, either you find out the short circuit current, dependent sources will be present always. Okay. Anyway, go through this small exercise, but very on your own you try to solve, and then it will be much more clearer to you what exactly you have to do while calculating currents in various branches of a circuit having both dependent and independent sources. Thank you.